Hello everybody, welcome back to my channel Explore Physics. So we were seeing quantum mechanics and till now we have completed two lectures, that is from basics of quantum mechanics. First we have seen the origin of quantum mechanics, and in the second lecture we have seen black body radiation. So now in this third lecture of quantum mechanics series we will be seeing photoelectric effect. So basically what is meant by photoelectric effect? So from the name itself we can say it is something related to photon, something related to the light. Light has what? Light has small packet of energy of particle known as photon. So basically it is the matter of photon. Alright. So first let me explain what is meant by a photoelectric effect. So basically, if let us say this is a metal surface we have, this is a metal surface. Alright. So when light, so what does a light has? Light has photons, right? Packet of photons, and these photons has got energy E is equal to h nu, where h is the Planck's constant and nu is the frequency of the light. So with this energy the incident radiation or incident light will strike the metal surface. So what happens is when a photon of energy E equal to h nu strikes the metal surface, what happens is the energy of this particular photon is transferred to the electron, and that electron is ejected out. So when this process happens, this is termed as photoelectric effect. Alright, is it clear? Now, as I told you, the incident radiation or incident photons has a frequency nu and energy equal to E equal to h nu. So at certain value of frequency, if it strikes, and then only it will give its energy to the electron, then only photoelectric effect happens. So if that minimum value of frequency, if it is not reached, then photoelectric effect doesn't take place. So the minimum value of frequency of the photons at which photoelectric effect takes place is known as nu naught. What is nu naught? It is the threshold value, threshold frequency, right? So what is threshold frequency? It is the minimum value of frequency of photons at which the photoelectric effect we can see. That is known as threshold frequency. Alright. Now as I told you in my previous lecture, before quantum mechanics we had classical mechanics, right? Before quantum mechanics we had classical mechanics. So what did classical mechanics believed is that, see, as I told you, this is our metal surface and this is a photon of energy E equal to h nu, and the electron comes out. The electrons get knocked out, and that is known as the photoelectric effect. So the classical mechanics believed that the kinetic energy of electron, what is kinetic energy? The energy with which the electron is coming out of the metal surface, that is referred as kinetic energy. That is the energy of movement, that is referred to as kinetic energy. So what did classical mechanics believed is that the kinetic energy of the ejected electron depends on the intensity of the incident photon. So as I told you, this is a photon which we are making it to incident on the metal surface. So classical mechanics believe that the kinetic energy of the ejected electron actually depends upon intensity. So this is what is said by classical mechanics. But so what is meant by intensity? Intensity means number of photons, right? Intensity means the number of photons value with which it will be giving the value of intensity. So intensity means number of photons. Alright, from the word itself we understand that intensity means the number of value of photons. Alright, so classical mechanics believe that the kinetic energy of ejected electron from the metal surface depends upon the intensity of incident photon, or the number of photon which is falling on the metal surface. This is what is believed by classical mechanics. But what did quantum mechanics actually believed? They concluded that kinetic energy of electron depends only on the frequency of the incident photon. It doesn't depend, it is independent of the intensity. That is, the kinetic energy of the ejected electron doesn't depend upon how many number of photon is falling on the metal surface. It is actually only depending on frequency. This I will be proving it in the later videos. So if you imagine, just imagine, this is your metal surface, right? This is your metal surface. Now this is a photon coming. This is your photon, which energy, what is the energy of photon? H nu, right? See, let me draw it again. So yeah, this is the metal surface, and this is the incident photon, and photon has energy E equal to h nu. The frequency of the photon is nu. So with this frequency, which is greater than nu naught. What is nu naught? Just I told you, nu naught is the minimum value of threshold frequency. That is, nu naught is actually threshold frequency. It is the minimum value of frequency, that is incident photons frequency, after which photoelectric effect takes place. So we have to keep in mind that whatever photon energy we are making it to strike on the metal surface, it should be greater than the threshold frequency. Only then we can see photoelectric effect, right? That I have already told you. So when this photon falls on it, when the frequency of the photon, when it is greater than threshold frequency, when it falls on it, it will transfer its energy to the electron. Now this electron has now the energy. So with this energy only it will move out. Electron gets ejected out. With which energy? The energy supplied by the photon to the electron, by which it helps in knocking out of electron from the shell of the metal surface. So this electron comes out. Now this electron has kinetic energy. So if you go behind and then see the history, from where this energy is coming? From the photon's energy. So we can say the kinetic energy depends on the what? Energy of the photon. What is energy of the photon? H nu. That means what? H is constant. So we can say kinetic energy is dependent on frequency of the incident photon. That was proved by classical mechanics. But sorry, quantum mechanics. What did classical mechanics say? It said that it is dependent on the intensity. That is, how much number of photons falls on the metal surface. That is the quantity with which the electrons, that is the kinetic energy of the electron will be. So which is actually wrong, because the kinetic energy of electron doesn't depend upon the intensity of the photon, incident photon. It only depends upon the frequency of the incident photon. Alright. So to sum up, the experimental observation they have found is that, so when the frequency, when it was lesser than the threshold frequency, what happened? There was no photoelectric effect. But when the incident frequency of the photon was greater than the threshold frequency nu naught, then we could see photoelectric effect. Another thing was what? This frequency is known as threshold frequency. That is a particular frequency below which we can't see any ejection of electron, or we can't see any photoelectric effect. And we also saw what? According to classical mechanics, what did it say? It said that the maximum value of kinetic energy, that is kinetic energy of the ejected electron, maximum value of kinetic energy of ejected electron, depends only on frequency and do not depend on intensity or the number of photons, right? So now we'll see Einstein's photoelectric effect equation. So Einstein photoelectric effect equation. Alright. So what is, see, this was the metal surface and this is a photon which has energy equal to h nu is striking the metal surface. So because of which when the frequency was greater than the threshold frequency, electron was ejected. So E of h nu, E is the energy of the photon, that h nu is actually what? It is the sum of the kinetic energy maximum of electron. So this energy is given to the electron, right? So kinetic energy maximum of electron plus there is some more energy given to something else, that is known as work function. So what is meant by work function is, so this electron will be somewhere inside this shell, right? So this is the atom is, so somewhere like this, inside this, let's say from this only the electron, or let's say somewhere here the electron is there. So when photon strikes here, it takes some, it absorbs energy and then it tries to come outside of the shell first. So it will try to get ejected out. It will come outside and then only it will start moving. So for motion only kinetic energy part is there. But to come outside of the shell, it requires some kind of energy and that energy is known as phi naught. What is phi naught? Work function. So the incident energy, that is incident photon has energy E equal to h nu. That energy is supplied to the internal electron to come out of the shell outside. That is one part of the energy is being used. The other part of the energy is used for its motion. So the kinetic energy is given to the electron which has come outside. So that is this. So from that theory we got this equation. Now this phi naught, work function phi naught is actually equal to h nu naught, because at this value of frequency, this is the threshold frequency, only at this value the electron will get ejected out, otherwise no photoelectric effect, right? So this is the work function. So we can rewrite and write it as, we can rewrite the same equation as our energy E is equal to h nu, that is equal to, we had kinetic energy maximum. So this energy was supplied to kinetic energy maximum as well as the work function h nu naught. So from this equation we can actually find the value of kinetic energy maximum. So kinetic energy maximum, that is if you want to find the maximum value of the ejected electron, maximum kinetic value of the ejected electron, or if you want to find with which velocity the ejected electron moves outside. So from that we will know from kinetic energy. So kinetic energy maximum is, take this h nu naught to the other side. So you will be getting h nu minus h nu naught. This is the Einstein photoelectric Einstein equation. I can take h common. So you will be getting nu minus nu naught. So this is kinetic energy maximum. Alright. So this is the expression that you have to remember. So from this equation itself, if you see case 1, when nu is greater than nu naught, what did we say? When the frequency is greater than threshold frequency, photoelectric effect takes place, right? So from this equation itself, if you see, this value is greater than nu naught. So that means nu minus nu naught will be a positive value. So kinetic energy is a positive quantity. That means it is correct. Kinetic energy is only positive only. We don't get the value of kinetic energy to be negative. That means this takes place. So we can see photoelectric effect. Second case was when nu is lesser than the threshold frequency. At this case what happens? So if you see nu is lesser than nu naught, that means if you take the difference you will be getting negative value. So now kinetic energy is becoming negative. Is it possible? We can't. Kinetic energy is a positive quantity. We won't get a negative quantity for kinetic energy. That means this process doesn't take place. So no photoelectric effect. So from the Einstein photoelectric equation itself, we can prove the concept of threshold frequency. All right. Now if you also see, we also know kinetic energy or energy equation, we can equate it with charge times potential. This we have learnt in maybe 11th or 12th itself. So this equation, charge times potential. We have kinetic energy. We can even equate it with what is the charge that is there in the photoelectric effect? Electron. Electron only it is ejected out, right? So electron energy charge is E, right? E times potential. Now this potential is actually stopping potential. Now this I will be explaining it in the next lecture. So in this lecture till this part, if you have any doubt, you can comment down and ask your query regarding the lecture till here. Further, I will be explaining about the different graph based on this concept, and again I will be explaining the concept of stopping potential using and again a diagram. I will be explaining what is this stopping potential and what is the use of stopping potential in the equation. Alright. So if you like this video, just share it with your friends as well as subscribe to my channel, and if you find this video to be useful, just comment down so that I'll get to know if you understood the video. So we'll see in the next lecture. Till then, bye.